हामी डिएससीको केही कुराहरू छलफल गर्नेछौँ। मैले केही कुरा पनि जान्दै जानेको छैन यो के जाति भन्छ यो डिएससीको डाटा स्ट्रक्चर एन्ड अल्गोरिदमको अब आजदेखि टपटप सुरु गर्ने हो है। कहाँ छ नोट? 168 पन्ना रहेछ। 168 पन्नाको नोट हामी आज पेज 1 पेज 1 मा रहेको छ, केही पनि छैन। Here, chapter 1, my introduction. It is the systematic process of organizing the collection of the data in order. Or data structure is the systematic process of storing and organizing the data in a computer system so that we can easily access and modify data. Systematic process हो रे organize data organize गर्ने, त्यसलाई collection गर्ने and process गर्ने, storage गर्ने, so we can have easy access to the data. अनि हामी डेटा स्ट्रक्चर हेर्छ भने प्रिमिटिभ हुन्छ, नन प्रिमिटिभ हुन्छ। प्रिमिटिभ भनेको पुरानो हुन्छ। प्रिमिटिभमा इन्टिजर पर्छ, फ्लोट पर्छ अनि पोइन्टर पर्छ। नन प्रिमिटिभमा एरे पर्छ, लिस्ट पर्छ अनि फाइल पर्छ रे। अनि लिनियर अनि नन लिनियर हुन्छ अरे। लिनियरमा स्ट्याक पर्छ अरे, क्यू पर्छ अरे, लिस्ट पर्छ अरे, ट्री पर्छ अरे अनि ग्राफ पर्छ अरे। अनि इम्पोर्टेन्ट पोजिसन टाइप्स अफ डेटा स्ट्रक्चर, लिनियर डेटा स्ट्रक्चर, नन लिनियर डेटा स्ट्रक्चर। लिनियर डेटा स्ट्रक्चर भनेको इट इज द टाइप अफ डेटा स्ट्रक्चर वेयर अल द एलिमेन्ट and data are stored in a sequential order. Linear मा चाहिँ where all types of data structure are the n element are added in a sequential order. Since the element are arranged in the sequential order, we can manage it easily. Example: array, stack, queue, linked list, etc. Array, it is the linear data structure in which all the data elements are arranged in the sequential order, where any similar type of data are stored. And A, B, C, 0, 1, 2 र stack is the linear data structure that follows the LIFO that stack भनेको linear data structure हो जसले चाहिँ LIFO principle follow गर्छ insertion and deletion through the side which is top of the stack. Top insert 4 3 2 1 0 E D C B A size 5. In this type of stack, mainly two operations are used: push insert element in the stack, pop delete element of the stack queue. Unlike the stack, the queue data structure work in the FIFO principle, where the insertion is done through the one side and deletion is done through the other side. Read front and it acts just like the queue in a ticket counter. Non linear data structure, those data structure where the data is represented in the hierarchical tree structure. It is the data structure transfer of the data. It cannot be done in a single run. A graph consists of the number of the node called the vertex, which is connected to each other by the each of the vertex. A tree, the similar graph or tree is also called the collection of the node in the is data structure in our algorithm. Insertion, adding a new data in the data structure is referred as the insertion. Deleting, removing the data from the data structure is referred as the deleting. Sorting, arranging the data in the some logical order, for example ascending or the descending the numbers. Searching, finding the location of the data in the data structure is called searching. Merging, combination of the data of the two different stored file in a single stored file. Transferring, visiting the every element of the data structure at least once is referred as the transferring. It is commonly used as a printing, reading and displaying the element stored in the data structure. Difference between linear and non-linear data structure. Data structure. Linear data structure are used to represent the sequential data. Non-linear data structure are used to represent the hierarchical data. It is easy to implement. It is difficult to implement. With basic linear data structure are the list, stack, and queue. The basic non-linear data structure are the tree and the graph. Data element can be transferred in a single run only. Data element cannot be transferred in a single run only. It is used in the application software development. It is used in the AI and image processing. And why the data structure important advantage? It helps to store information securely in the computer system. It helps to access and process the data efficiently. By the help of data structure, we can transfer all the element data easily and efficiently. Disadvantage of the data structure: advantage, computer expertise is required to alter the data in the data structure. It is hard to implement and manage abstract data type. Abstraction means the showing the essential information and hiding its in implementation in ADT. ADT is a mathematical model of the data structure that specifies the type of data stored, the operation supported by them, and the type of parameter of the operation. ADT is a type and class for the object whose behavior is defined by the set of the value and set of the operation. The definition of the ADT only mention that what the operation are to be performed, but now not now this operation will be performed. ADT is made of a primitive data type, but logic operation are hidden in the inside stack. Queue, link, list, etc. Stack on ADT. Empty, push, pop. Size is full. Peak. Queue is full. Is empty. Insert size. List, insert, remove, get, it, I, replace, XY size. Difference between the stack and the queue: stack is a linear data structure based on the LIFO principle. Queue is a linear data structure based on the FIFO principle. In the stack, insertion and deletion is performed at the stack. In the queue, insertion and deletion are performed at the different. In a stack, one pointer is used to is in it is called the top of the stack. In the queue, two pointer are used. They are called the follower and rear end. Stack operation are called the push and pop. Queue operation are called the key in queue and dequeue. It is visualized at the vertical collection. It is visual at the horizontal collection. There is no wastage of the memory space. There is wastage of the memory space. Example: collecting plate and of the wedding or the marriage. Example: line of the ticket counter. Chapter 2: stack application. Reversion of the stack is reversion. Undo, redo, balance, parenthesis, implementation of the recursion, evaluation, postfix, prefix, infix, push operation is used to insert an element in a stack. To insert an element in a stack, first we check whether the stack is full or not. If the stack is full, then the condition is stack overflow algorithm. For the push operation step start if top is max size, current stack is full or the overflow is, and go to step 5. Top step top plus 1, set state top value data in. Write a condition for the overflow top max size pop operation. When we remove an item, we can say that we pop into the stack, and when an item is popped, it always the top the item. When the item is removed, it is the stack empty or the as the null data. And this condition is called the stack underflow algorithm or the pop operation. Stack top the stack is empty or the stack set stack value stack top end. Stack as an edit struct void push pop void display void push pop top max size stack overflow is top plus one stack top value infix postfix prefix notation. Notation: the way of arithmetic operation expression is known as the notation. Infix operator appears between the two operation operator a plus b operand. Prefix operator appears before its expression. Parenthesis pre expression also called an Polish notation. Example: tab is prefix of a plus b. Postfix operator appears after as in operand. Parenthesis pre expression also called the reverse Polish notation. For example, ABT, the postfix a plus b. Postfix operation are most suitable to calculate any expression in the computer. It is universally and logical unit of the CPU. Any expression entered to the text is called the first converted into the postfix notation in the stack, and then it is calculated in fixed order of the operation. Parenthesis exponential right or the left multiplication and the division, subtraction and addition, conversion of the infix expression to the postfix, and postfix of the notation a plus b infix a plus b into c a plus b minus c into d a plus b into c minus infix prefix a plus b b into c a plus b b into c a plus a into b c postfix plus a b into c a plus b c into b b c into is operand a b c plus a b c into prefix a b c into c a b plus into c into a into plus b a b c postfix a plus b into c a plus b into c a b c into c a plus b minus c into d prefix a plus b minus c into d, a plus minus bc into d, a plus x base cd, operand plus a plus minus bcd, postfix a plus bc minus a into 1, a plus b minus c, a plus bcd, a plus bcd algorithm to evaluate the postfix operation. Make an empty stack on the appendix in scan the input postfix is screened from the left to the right for each symbol is the input positive string. If the symbol is an operand push type into the stack operand to pop or an operand from the opposite which is on top of the element. Operand one pop an operand from the stack which is the next step of the stack and the stick value the result of applying the symbol and operand one operand two and push value into the stack pop value of the operand stack which is require result 1 2 3 into 1 to symbol one operand two value operand stack symbol operand one operand two value operand stack 1 2 ABC convert the prefix ABC. Write the algorithm to convert the infix expression into the postfix expression using syntax A plus B syntax stack postfix A plus B C into C minus C precedence higher order lower order no same norm the sum person can be to the associately right to left to right pop right to left academic bracket wall and broke abc plus into the infix to the prefix is step 2 step 1 reverse postfix is step 3 reverse convert into the prefix abc into c abc reverse abc plus d abc syntax stack postfix abc e plus b into c c abc c c c 5 abc 2 to 2 reverse abc algorithm to convert the infix to the postfix expression using stack initialize the stack scan the operator from the left to the right in the infix expression the leftmost character is an operand set if it is current output into the postfix screen and if the scan character is operand and the stack is empty or content the draw the push an operator to the stack if the scan the character is left bracket push to the stack, we get encounter to the right bracket, pop the stack and print all output until the is encounter and discard the both bracket. Repeat the step and flow from 1 to and 2 until the infix expression is is can print the stack output pop and output all the character including the operator from the stack until it is not empty. Chapter 3 Q is a linear data structure that follows the FIFO principle. In Q, insertion is done. DQ, delete, deletion, front is full. Check the Q is full or not. Empty or not. Size, get size of the Q. Pick, get the value in front of without removing it. Rear in Q. Rear DQ algorithm for the in Q operation start if rear max has 1, then the Q is full of overflow got into step 1 else rear plus 1 q rear is equal to data in algorithm for the dq operation start condition front rear the q is empty and underflow and go to step 5. The dq element is downshift data q front plus 1 in evaluation 574 minus 84 into 7 symbol operand to value stack. Converting the infix to the postfix using the style p plus q r into s t plus 4 b into w syntax operator stack postfix. Assignment application of the q types and application arranging the recursion single chart set and search and scheduling and disk scheduling handling the ad hoc or the real-time system. Real-time handling router and switches in the networking, maintaining the playlist in the media player type of the queue, simple queue or the linear queue. In the simple queue, insertion of the data takes place from the rear end and the deletion takes place from the front end. Follow the FIFO principle. The major drawbacks using the simple queue is insertion takes place on any rear end and only the element are deleted from the queue. We cannot insert the more element even though space is available. In this case, it shows the overflow as the rear is pointing to the last element of the queue layer. Circular queue is a similar linear queue that allow the pivot principle in which the last position is connected to the first position in a circular queue. It forms a circular thrust known as the ring suffer. It overcomes the simple queue drawbacks. If the empty space is available, the new element can be added in it, and by simply the maintaining the value of rear, it has within better memory utilization. Priority queue, it is a special queue in which the elements are arranged and based on the parity. Suppose some element have same parity, it will be arranged according to the FIFO principle. Insertion in the parity queue takes place based on the arrival, which deletion is the parity queue occurs based on the parity, and it is used to CPU scheduling the types of the parity queue. Ascending parity queue, in this queue the all the element can be inserted, but the deletion takes place in the smallest element. Suppose the array with the element we can insert in same way, but the order of the deletion will be the 239. Descending parity queue, insertion of the element can be anything as the deletion will take place. Large sub element DQ double indeed queue, the DQ insertion and the deletion can be done from the both in and either from the front or the rear. Limitation of the queue front and rear rear. Limitation, we cannot insert 64. We have O10 first place empty rear max queue, so it is shown in the queue is full to overcome whenever an element is deleted. Shift all the afterward element to the left by one position. If the queue is too large, we can use the circular queue. Application of the queue. Call center uses the queue to hold the people. Operation system uses it handle the after different tax writing for the principal algorithm for the in queue operation in a circular queue. Start if the front or rear plus one max size of the queue gota. And if front is set front rear one yields rear 0 plus 1 DQ stop. Algorithm for the DQ and operation in the circular queue starts G of front is equal to 1 print error. Circular queue is underflow and go to the step for data queue front rear set front max has the step front rear. Algorithm for the in-queue operation in the circular queue study front rear plus one max has overflow and go to step back. If the front set rear yields rear plus one max has the queue rear value stop working. Max has 3 initially and empty circular queue in the in front minus 1 plus 1 positive 3. Take the value as a 10 if front is equal to minus 1. Yield shift taken value if the front is 0 take false yields rear plus 0 plus 1 1.3 rear. If the front is 0, let's suppose the element is deleted circular queue. If front rear max size 1.1 3.3 0.3 false if the take value to the front yield shift rear. Algorithm for working the DQ operation in the circular key. If A is front 0 1 false yields data queue front data 0 0 front rear 0 2 10 is double yields data is q front rear false yields front 2.13 20 is deleted data 30 if the front rear setup is equal to minus 1 setup is 30 is deleted QE as in ADT. It talks about the operation. The Q abstract data type is defined by the following structure and the operation of Q structure in which the element are added in one end and the rear end added to the other end. And form it is focus on the FIFO principle. The Q operation in Q insert acts at the rear end and the DQ in queue removes the front item from the queue. Full checks the queue if it is full. If the full return true, otherwise false. It is empty. Checks the queue is empty. If the empty return pick get the value from the front without removing it from the queue. Make empty to make example. Queue is empty. Queue is in queue. Queue is in queue. Peak size a peak. Rear plus inserting data return implementation of the DQ. DQ is empty return in the data queue front. Operation linear queue is a queue which in an element is inserted in one in called the rear and deleted is in the in called the front queue. A circular queue is a queue which the last position is connected to the first position if the space is available. Queue is rear and pointer to the last queue and queue we cannot insert an element. How we can solve the limitation of the linear queue in the circular queue? ओके, आज चाहिँ 40 पेज पढ्यो, भोलि फेरि 40 पेज हुन्छ। धन्यवाद।